Module 4, Lesson 26, is on the characterization of parallel lines. Basically, we're still dealing with systems, and we're going to start dealing with the types of solutions we get with these systems. So, this first is a really good review of how we solve a system of equations with graphing. Sketch graphs of this linear system. Excuse me. So, let's start with this first one here. Y equals 2/3 times x plus 4. I want you to remember that this is in slope-intercept form. Y equals mx plus b. Okay, and again, it can be b plus mx. The important things to remember is whatever's being added on is our y-intercept, and whatever is the coefficient of x is our slope, rise over run. So I can say here that our y-intercept is 4, because it's what's being added on, and our slope, if I spell it correctly, is 2/3. Now remembering when we graph, we start our steps, say we start by going to our y-axis and plotting our y-intercept. So I put a dot there at 4. And then I apply my slope from this point. Remember, slope is rise over run. So I'm going to rise 2, positive 2 going up 2, and then I'm going to go to the right 3. Okay? And then I'm going to draw a nice line through there. And again, like I've told you before, really be careful about your lines. Just it makes it easier when you're a little more exact with them. Okay? All right. Then I am going to do the next one. So that line represents all the pairings of x and y values that make this true. So now I want to do the same thing for y equals 6 times x minus 3. Now instead of writing minus 3, I'm going to go plus a negative 3. Our y-intercept then, and this is why it's important that we change it to addition. Remember, our y-intercept is y equals mx plus b. B is our y-intercept. It's what's being added on. So if it's subtraction, you got to change it to addition. Easy to do. It's just important to remember how to do it. So our y-intercept is a negative 3, and our slope is 4/6. Rise 4, run 6. Okay, so we're going to start by plotting our y-intercept. So go to my y-axis at negative 3, put a dot, and from here I'm going to rise 4, 1, 2, 3, 4, and run 6. Go to the right 6. 1, 2, 3, 4, 5, 6. Then I get my line. And run my line through it here. Okay. All right, so that is sketching a linear system, looking for the intersection point, because remember the intersection point is the point that makes them both true statements. So let's identify the slope of each one. Well, we kind of already did that. So the first one was 2/3, and the second one here was 4/6. But what do we know we can do to 4/6? We can reduce it, right? Divide both of them by 2, and that's 2/3. Notice that these are the same slope. So now let's look at our lines. It's the same slope. What do we notice about these lines? If we do our lines correctly, they should look like parallel lines, right? Word of caution. Sometimes lines look parallel, but they're not exactly parallel. So if you're unsure at all, find your slope. Pick 2 points and go rise, run, and see if they reduce to the same thing. There's a hint for your homework. All right, identify the y-intercepts. Well, in our blue line here, it's 4. In our pink line, it's negative 3. And they have different y-intercepts. So, what is the solution to the system? What point do they intersect at? Okay, so we would say that there is no solution to this. Okay, we'll talk more about that later. But if this is all the pairings of x and y that make this first equation true, and this is all the pairings of x and y's that make the second equation true, there is no point that makes them both true. No solution. Okay, so let's look at another example. Again, guys, feel free to pause it if you need to write anything down, or rewind it if you need to hear something again. Okay, so hopefully from the last one, we're starting to see something right away right with this. But if not, let's go through our steps. Let's sketch this again. So I'm going to start with y equals negative 5/4. So I want you to notice that I put the negative up with the 5/4, and I'm going to talk about that in a second. Okay. We can say then our y-intercept is what's being added on, in this case, which is 7. And our slope is the coefficient of x. It's negative 5/4. You can write it as a negative 5/4 or a positive 5 over a negative 4. I'm going to show you why you can do it either. But what you cannot do is this. You cannot make them both negative. Here's the reason why. If you take a negative and you divide it by a negative, it becomes a positive. This is not a positive slope. Don't do that. Either put the negative up top or on the bottom. Okay? So let's graph it. Y-intercept is 7. Okay? If I think of it as negative 5/4, I'm going to go down 5. 1, 2, 3, 4, 5, and to the right 4. Okay? I could think of it as rising 5 and going to the left 4. Now, I can't really do that on the graph here, but if you kind of picture it, if I were to go up 1, 2, 3, 4, 5, and then negative 4 means go left 4, 1, 2, 3, 4. Do you guys see how that would, if I did a better job, fall on that line? Okay, that's why you can do either one. And I probably negative 5/4 here. A lot of times, guys, it's helpful to go down 5 again. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, because then more points means your lines can be more exact. It just makes it a little bit easier. Okay. All right, let's look at the next one. And that keeps wanting to pop up. All right. Now we have y equals negative 5/4 x plus 2. So my y-intercept is 2. And again, my slope is going to be a negative 5/4 or 5 over a negative 4. Let's see if we can do the other way this time. Y-axis, go to 2, positive 2, sorry. And let's do down 5. 1, 2, 3, 4, 5, into the right 4. 1, 2, 3, 4. Or what if we went up 5? 1, 2, 3, 4, 5, into the left 4. 1, 2, 3, 4. That one worked out, okay? That's why you can use either one, okay? It's negative. As we read it from left to right, the graph's going down, which it should be because it's a negative slope. All right, so get my line fixed up here. And, okay, identify the slope of each equation. Well, they're both negative 5/4. And that would mean that they're the same. Look at their y-intercepts. We had 7 and 2. And they're different y-intercepts. Okay, so what is their solution? Well, they're parallel lines. Parallel lines come from the same slope. They're the same slope. They're always going to stay the same distance away from each other. And if they're parallel lines with the same slope, that again means there's no solution.